What's going on, people of the internet, people on YouTube? My name is Johnny Bannon with Technologies, and today we're going to be going over Rapid Spanning Tree Protocol. So this is going to be video 2 to our Spanning Tree series. I need you guys to click that link below to go on Trepid Technologies Confluence how-to page. Alright guys, so first things first, let's go on Confluence. So here, I have all my stuff on Spanning Tree, guys. And if you watched my last video, that's where I give a little explanation to Spanning Tree. I hope I did a good job for anyone watching. It is a hard topic to teach. And then today, we're going to go over Rapid Spanning Tree, right? So all the logic about the loop prevention in Spanning Tree still holds in Rapid Spanning Tree. We get some different configuration, I guess, right? We have something called these edge ports, which I'll show you what that does. And then in Cisco ROS, we know we do Rapid Spanning Tree on a per VLAN basis. And then Rapid Spanning Tree converges much, much faster, right? It doesn't actually have the listening and learning state. It goes to learning, to forwarding, or discarding, right? It's 3 states instead of the 5 states. I think 5 states on Spanning Tree. Let's check actually. How many states does regular Spanning Tree have? So 4, right? I guess if you consider disabled, that port role, right? State, but we have 4 right there and 3 right here. Yeah, I guess some people do consider disabled a port state. I'm pretty sure on test they will too. Let's get back to Rapid Spanning Tree. So first things first, guys, I'm going to show you how to change the Rapid Spanning Tree mode. And then we're going to do some show commands, and then we're going to show you how to configure this edge trunk port. So what this does is just automatically set it, right? Saying, hey, this is the edge. There's really nowhere else I can go. I need to send my traffic to this root bridge, right? To switch 1, or to the core switch, or to the switch directly connected to the router. I've done this in the live network a lot, actually. And one of the enterprises I was working at, we had ISR routers with switch modules in them. I forget what they're actually called, but essentially, yeah, switch modules in the big router. And that would always be our root switch. So the switch directly connected to that, or any switch directly connected to that, we would put that command in because there should be nowhere else it could go, right? Because that switch is closest to the router, closest to the edge. So with that being said, and that logic and info now with us, let's set up our GNS3 topology. I think I have it in here. RSTP, let's bring that up. Surely not, that's okay. We can just make the topology, right? It's always good to see how someone makes it. Make this switch 3. Make this switch 2. Make this switch 1. Now let's go back to make sure I'm doing the ports right. So down on switch 1, we have gig 1, 1, and 2, 0, and 2, 1. So 1, 1, 1, 0. 1, 0 over here. I always make them the same on both ends. Ah, see, that's not it. Let's try this again, right? 1, 1, and 1, 0. Come on now. 1, 1. 1, 0. Awesome. Let's go back. 2, 0, 2, 1. So switch 3, switch 1. All right. And now we got 3, 2, and 3, 3 at the bottom here. 3, 2. 3, 3. Let's start this up. We'll clean this up a little bit, guys. Just a little bit, right? Clean this up. Look, we have a guest appearance, my girlfriend. What up? All right, guys, back to some networking, right? Yes, network engineers can have girlfriends, guys. Don't be scared of IT. It is cool nowadays. And let's console into these bad boys. So I'm gonna do some basic, what Cisco likes to call housekeeping, right? When I was a CCNA instructor, I taught my students that this was housekeeping. We're doing housekeeping commands to make it easy for us. Get this over here. We'll do this on all the switches. Switch 2, we'll go into line con 0, logging synchronous. That stops the syslog messages that appear from cutting us off, right? This is a must-have. There's some other basic housekeeping commands, but in all my routing videos, you see my baselines, and that pretty much covers all the housekeeping that I do on my devices, so be sure to check those videos out. And now let's configure some trunks, guys. So on switch 1, we had 1011, 2021. So interface range gig 1/0 through 1, comma gig 2/0 through 1. Here you have to define encapsulation. Then we do switch from mode trunk. And you know what? This is a video on RSTP. Alright, let's see here. So I'm just gonna grab this. So this one, I guess I got lazy, guys, and didn't put all the configuration for the switches. Shame on me. Interface range gig 2/0 through 1. Usually I like to do that for you guys, so if you know the technologies to get started, we can just move. Oh, gotta do trunking on that. Come on now. So if you know the technologies, that you can just skip ahead to the actual thing you're learning. And here it's rapid spanning tree. So of course, first thing we're going to do is create VLANs in all these. VLANs 10 through 15, exit. VLAN 10 through 15, exit. And if you're on a Windows computer, guys, I suggest getting Secure CRT. There is one you can do for Ubuntu, but a Secure CRT will give you all the tabs, so you don't have to do what I'm doing. You can just send a command to all your interfaces, or all your devices using Secure CRT. I just haven't installed it on Ubuntu yet. It was kind of buggy when I tried and just haven't taken the time to do it. So now let's check our spanning tree instance for VLAN 10. When I'm doing these videos, I only like to work with one VLAN, guys, and that's because it's just too crazy to actually look at all the VLAN instances, right? Crazy. Okay, guys. So let's make switch 1 our root, right, as it should be. So we could tell that it wasn't our root bridge because our root bridge will have all designated ports, and it will actually say up here that this is the root bridge when we do our show commands. So we'll do spanning tree VLAN 10 priority 4096, and now it'll do reconversions. Just those spanning tree VLAN 10, show you how quick this is. Boom, already gone. Already done skis. Already reconverged. So if I do show spanning tree VLAN 11, we're going to see that in VLAN 11, this is not the root bridge like we are for VLAN 10. And that's because you set priority, you set the bridge ID on a per VLAN basis, guys. All right. Let's go back to our Confluence page. And now what we want to do is make an edge port, okay? And we're going to show you how to make the spanning tree mode rapid PVST. So that's rapid per VLAN spanning tree. It's easy. So if we weren't using rapid spanning tree, we could change the mode like this. And if you weren't aware, if one of the switches in here was doing STP, we would default back down to the legacy. That's what documentation tells us. Let's see. See that? It says we're still using RSTP, but here it says we're using STP. So it should be backwards compatible. Okay, so it says here up here is STP. I think it still actually will use STP logic now in the entire topology. We have to look at the documentation, but let's change that mode back down to rapid. All right, guys. Now let's go to switch 2. Let's go ahead and make whatever our root port is for VLAN 10 the edge, right? Let's go back to Confluence. So what we'd actually have to do here to make this work, well, we don't have to change the priority of all the VLAN instances. When we put this command, no matter what, switch 2 is just going to send everything to switch 1, right? Let's do it. So let's go into interface gig1/0. Go to spanning tree, port fast, edge, trunk, because we have trunk ports. So again, in this topology, we actually wouldn't want to do this, guys, right? Because we have 2 ports redundancy and we have a little triangle configuration. But if we did something like this, and then got rid of this, and then we had users right here connected to switch 3, that command would be perfect. Because there's really only one way to go. If this was the root bridge, it wouldn't really make much sense, right? Because we're assuming that this switch is connected to our internet, right? It's closest to our WAN. So obviously, we want this to only forward traffic here. We wouldn't want this to be the root bridge. It just wouldn't make sense. That's an easy way to do that. So doing that command is an easy way to tell this switch, hey, just forward all traffic, right? Without having to do the STP convergence or election. All right, guys. So that's all I have for rapid spanning tree. Again, remember that Cisco per VLAN basis, rapid spanning tree just builds on the logic of regular spanning tree, the 802.1d RFC, right? The IEEE standard. And from everyone here at Trevor Technologies, I hope you enjoyed. Thank you for viewing. And remember to keep learning every single day.